So in this coming session, a virtual session, we'll be doing the FM transmitter project, which is one of the main activities for the STEM clubs. So the goal of this project is to build your own radio phone from which you can transmit, where you can speak and transmit your voice, and from and actually hear it being played from your radio, say in the car or something. So the students will build their own FM transmitter. So just some of the background. Uh, how do we commonly communicate in this digital world? So one way to categorize it is in terms of wired and wireless. So in a wired network, we have connections like coaxial cables or fiber optics, which carry the information from one point to another. In a wireless system, uh, the information is transmitted uh, through a wired channel onto a transmitter, and from there it's broadcast into space, and the receiver has a mechanism of receiving those waves and converting it back to the original information. So this information is carried in the form of electromagnetic waves, which we call EM waves, right? So we may ask a question, why is voice encoded in electromagnetic waves? And the reason for that is that voice frequency is in the range of 20 hertz to 20,000 hertz. So that is a frequency in which we can speak. And these are very low frequencies. They die down quickly when transmitted over space. Even with a lot of amplification, it will not be able to make it through a few miles and so on. So what happens is that uh, a voice signal, a low frequency signal, dies down because of damping effects in the atmosphere. So what we have to do is kind of attach a high frequency wave on top of this information signal or the voice signal, to be able to make it all the way to the next point. So this high frequency wave is called a carrier wave. You can think of it like a bus, and this information signal as the passenger, and the bus carries the passenger to the destination. This So what do I mean by attach? So attach can be in several ways, and this process of attaching a high frequency wave to the voice signal is called modulation. So there are basically two types of modulation: amplitude modulation and frequency modulation. So amplitude modulation is the modulation of the amplitude of the information signal or the voice signal. So it's very simple. So when the amplitude of the voice, when we speak, is high, the amplitude of the carrier is made high. Amplitude is low, the amplitude of the carrier is made low. So the amplitude of the carrier is modulated according to the voice signal. So this, if we go to our app here, which you've all seen before, so and you select AM player, so you can see the first is the data wave or the voice signal, which is a low frequency wave of 100 hertz. And this is the high frequency carrier wave or the bus, which I compared it to. So when how do I attach it? Means I multiply the two. So what happens is, at this point of time, amplitude of the data signal is high. So you see the amplitude of this AM wave is high. Here it's low, here it's low, and here it's low. So the information signal actually forms the envelope of the AM wave. So it's still present here. If we know how to decode this signal, we'll be able to extract this. But it's a high frequency carrier, so it can make it through large distances. So similarly, now FM modulation is the modulation of the frequency. So when amplitude of the voice is high, the frequency of the carrier is made high, and when the amplitude is low, frequency of the carrier is made low. So amplitude of the carrier here remains constant. As in this case, the frequency remains constant. Here amplitude remains constant. The frequency is varied. So again, let's go to our app and choose FM player. So you see the same data signal, the same carrier signal, and this is the FM wave. So the amplitude is always 1, it's not changed. But let me increase this so that it becomes more clear. So you see, when amplitude is high, like it's 1 here, the frequency, this oscillations happen fast. And amplitude is low, it's -1, oscillations happen slowly. So the information of this wave is contained within this wave, but in its frequency, not in its amplitude. So this is called FM modulation or FM. So what is the difference? Like, why do we do one over the other? What are the differences in performance? So FM generally has better quality or fidelity. It is less affected by noise. So it's used for transmitting music in which we hear on the radio, because we need that music to be high quality. Whereas AM has better range, it can travel longer distances. So we use it for broadcasting news, because that's important. Everyone in the county needs to hear that. So we need to send it through AM. It doesn't matter that it's not the most high quality. So AM has a different purpose. FM has a range of 88 megahertz to 108 megahertz. AM has range of 535 kilohertz to 1705 kilohertz. So as a refresher, this is our voice signal. AM looks like this. The amplitude is varied, and FM looks like this. The frequency is varied. Now let's go on to actually building the components of an FM transmitter. So we'll go through it simplistically, and on the actual session, you will assemble these things together. So the first component is a speaker. They speak. They produce a voice signal, and this voice signal has to be converted into a voltage, because to do anything with circuits and electronics, we need the signal to be in a voltage form. So we use a microphone which does exactly that. It converts sound to electricity. And then what we see here is that the voice may look something like this. So the amplitude variation is very small, and this is not enough to overcome the noise. So we need to amplify it, and the component that's used is a transistor. This is the building block of almost every electronic device you'll find is the transistor. It's used for amplification. It's one of its major uses is in amplification. So it amplifies the signal without distorting its shape. And then this is but we have still not done the modulation. This is just amplification. So to do modulation, we need to build this circuit. The functioning of the circuit in a overall way can be thought of as follows. So this part here, this is an inductor L. This trim cap is a capacitor. So this thing is called a tank circuit. So by tuning this capacitor, we can produce different frequencies of carrier waves. So the high frequency wave is generated from this part. This data signal is input here, and these components, this transistor and capacitors, help to modulate the frequency of this wave according to the amplitude of this wave. So FM transmission happens, and then we need an antenna to transmit that into free space, to transmit that voltage variation into free space. And then it's sent through the space and it's received by transmitter. So we'll build all of this in circuit. Okay, so for the activity on 30th, we'll have basically two parts. So the first part is you'll build this circuit, which is shown in figure 8.10. So please have a look at it, and there will be provided a worksheet where you'll mark all the nodes where you want to connect the breadboard, where the parts on the breadboard. So what this circuit is doing is showing you the effect of the capacitor. So we have a microphone. It's provided in your kit. The polarity of the microphone is also explained. in the handout. And so the voice signal is converted to electrical signal, but it has a offset. So this is a constant DC offset. So the capacitor blocks DC, so you should be able to see uh, the same signal but without a DC component. So there is no amplification at this point. So at this point, we are here. So this is activity number 1. And you will measure the voltages here, between here and here, black and red, and black and red. So this is before the capacitor, this is after the capacitor, using a multimeter, using the AC and DC settings. The second activity is to add on to that circuit a transistor. So here we have come up to the stage, we want to do amplification, right? So we add some more components to act as an amplifier for this signal that we measured in the previous case. So we can see that we hope to see that a signal actually gets amplified. So you measure voltages here before, and at the collector of this transistor, and at the output of this capacitor, and hopefully we should see amplification of this signal. Yes, and the third part, which is a post-session assignment, is for you to add on to it this circuit. The worksheet will be provided, which will help guide you through where to connect these. But otherwise, it's just an addition onto this already pre-built circuit. And all the parts are provided. And you will be asked to measure voltages at certain locations and upload it into the Moodle as the assignment. So thank you very much. We'll see you on 30th.